is formed in both ends. So this circuit is like as the pi-type network. So these are basically method of calculation. By considering this capacitance, we can calculate the efficiency and regulation of the transmission line. In case of long transmission line, here you see the voltage, the length of the transmission line, which is above 100 kilometer, and voltage is above 100 kilo. That means here there are no way to consider the parameters. As the voltage level is high, so we consider what we think practically whatever capacitance will be formed in between the conductor, this is over through the transmission line. So there is no way to consider the capacitance. Only we consider here, we consider there, and we have considered in case of medium transmission line and short transmission line. Okay. So that's why in case of long transmission line, we consider a different method. By means of this, we get the, or we can analyze the efficiency. We can analyze or we can analyze the efficiency also. What is this? Rigorous method. This is the most practical method to calculate the transmission line. Okay. Most practical method. So here I will ask one question to you. See, suppose in case of short transmission line, you get 96% efficiency. Suppose in case of medium transmission line, these are the analytical method. We consider the capacitance. Okay. Here we get 94% efficiency. And by means of this rigorous method, you get 89% efficiency. So which is most appropriate efficiency for the transmission line? Obviously consider this 89%, because this is the practical method. Here you analyze by means of considering this line resistance, line inductance, but practically here we not do this. Practically there is some difference are here. Here you consider the idea. Now see. First of all, I will draw one basic diagram of the transmission line. Afterward, you get what are the parameters are there and all nomenclature of this transmission line. See. Here I consider this is line resistance, this is line inductance. Okay. This is line resistance, this is line inductance, XL or L, whatever you write. This input voltage is called sending end voltage. The output voltage is called receiving end voltage. What I have told you, Vs is the sending end voltage. Here, what I have told you, receiving end voltage. Whatever current you just go through here, so this is called sending end current. At the receiving end, it is called receiving end current. But for that case, we know in series circuit the current flow to each and every component is same. That means here we can say Is equal to IR equal to I. Same. That means Is is the sending end current, IR is the receiving current. Okay. Now see how we get the regulation from here. That's why I have drawn this circuit. How get the regulation? Whatever the difference in voltage between the sending end and receiving end to the receiving end voltage, this is the ratio. Now you think, as I have told you, this is your regulation. How the regulation will differ. Suppose the line resistance and inductance are there. This drop is more. The drop more means you get the less voltage at the receiving end, right? So less voltage means the difference of this thing, difference of the sending end and receiving end voltage will get more, and thereby the regulation of the line is poor. That means performance of line is the poor because the line has huge losses. Now you think the drop is very less. Very less means suppose if you consider the 200 to 20 voltage input, you are getting 219 voltage output. That means 1 volt drop is there. So that will represent the line regulation is better. Also, we can determine the regulation considering VR0 minus VR. That means receiving end no load voltage. VR0 means the difference between receiving end no load voltage to the receiving end voltage. You can also get the regulation. Okay. How to get the efficiency from here? If I know the Vs is the sending end voltage, VR is the receiving end voltage. See, so can you identify from here the input power and output power respectively? What is the basic efficiency? Efficiency means efficiency means see. Output power to the input power. Okay. What is the output power from here? If VR is the receiving end voltage, IR is the receiving end current, cos phi is the receiving end power factor to the input power. Input power means Vs, Is, cos phi s. Cos phi is the receiving end power factor. Cos phi is the sending end power factor. Okay. And also you can get, you know, again we can get the efficiency. If you want to get the percentage, so you can put here multiplied by 100. You can put here multiplied by 100. Again we know the input power can be represented. Input power output power plus losses. Output power means already you get here IR cos phi. Losses means how much power losses is there. If I consider this is Rx, so we can put here Z is the impedance. So current I is the current. or you can put here the I is the resistance. This is you can find I square J R square. Okay. So this is the way of calculation of the efficiency. Now one question can come in your mind. In our transmission line, basically all transmission line is distributed in 3 phase, but here I have drawn a single resistance, single inductance. How we do this? See. If I consider this is 3-phase input, okay? 3-phase input. And this is the 3-phase output terminal. Red, yellow, blue, red, yellow, blue. So you connect. So this is the line thing, line resistance and inductance. Blue. Basically all transmission line is 3-phase transmission line. But for our easy calculation, we only consider a single phase. That's why you get this kind of diagram. See. That means 1/3 we calculate the 1/3 of the transmission line, not the total. Whatever power you will get, this is the 1/3 power. Okay. So is it clear how you get about the performance of the transmission line? And in the next class I shall discuss the all categories of the transmission line, considering the short transmission line, medium transmission line and long transmission line and the phasor diagram respectively. Thank you.